All right, good morning. We are learning about zero and negative exponents. There are two rules. You need to write these in your journals. For zero exponents, any non-zero number to the zero power is equal to 1. Always, 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 guys. If you ever get 0 to the 0, that's undefined. That's not a solvable answer. So if you ever see that, just write undefined. But other than that, anytime you have a whole number, 3 to the power of 0 equals 1. 5 to the power of 0 equals 1. 372,123 to the power of 0, 1. Okay? So if you ever see to the power of 0, the answer is 1. Write that in your journals. Okay? For negative exponents, for any integer n and any number a that's not equal to 0, a to the power of a negative exponent is equal to 1 divided by a to that next exponent. Okay, so again, you can't have 0 stuff here. But if you have, I'm just going to use their example, 4 to the negative 1/2, you cannot, they don't like leaving a negative in here. So the proper way to rewrite this is to put it all underneath 1 and take away the exponent. So 4 to the 2. Now you could actually solve that. 4 squared would be 1 over 16. So this would actually be the solved answer, but the simplified version is 1 over 4 squared. So if you ever see 4 to the negative of any number, you just put it under the number 1 and make it a positive exponent. All right, so let's do example 1. Okay, so you want to write this in your journals. Example 1. So you have 3 to the power of a negative 4. Oh, and this wants you to solve it, by the way, so we are going to simplify this all the way down. So 3 to the power of negative 4, you would just rewrite as 1 over 3 to the positive 4. And then you simplify that. 1 goes on top, and 3 times 3 times 3 times 3 will give you 81. So the answer to 3 to the negative 4 would be 1 over 81. Okay, so negative exponent, just put it underneath a 1. What if I have a negative 8.5 to the power of negative 4 times a negative 8.5 to the power of negative 4, or to the power of positive 4? Okay, well remember, when you're multiplying bases that are the same base, you add the exponents. So you see here we simplified it to, we only wrote the base one time, and we have a negative 4 plus a 4. Well, what's negative 4 plus 4? 0. So that means we have negative 8.5, or whatever base number they have, to the power of 0. Well, any number to the power of 0 is 1. Okay, so you do have to do multiple steps sometimes. When you're multiplying bases with the same base, you add the exponents. This is a rule from a lesson or two ago. Make sure you have your journals so you can use this. All right, now let's look at C. 2 over 6, 2 to the power of 6 over 2 to the power of 8. These are dividing exponents, or dividing powers. Man, I can't talk today. Dividing bases with the same base. So when you're doing division, you do subtraction. Well, you notice when I subtract 6 minus 8, I get a negative number. That's okay, because then we just simplify this and say 1 over 2 to the power of 2. Then you can solve that. 2 to the power of 2 is 4, so your answer would be 1 over 4. These are all very important rules to make sure you understand. So make sure you have this in your journal. Good. All right, so let's do some on your owns. All right, on your own number 1. First thing, you see that's a negative exponent. So when it's a negative exponent, I'm just going to put it underneath the 1, 4 to the power of 2. Then I can simplify that. What is 4 to the power of 2? 4 times 4 would be 16. So my answer is 1 over 16. Good. All right, now this one's trying to trick you. You see how we have a negative base and a negative exponent. Well, first thing, simplify it to have 1 over negative 2 to the power of 5. Okay, so there's simplified. Now I solve it. Well, negative 2 times negative 2 times negative 2 5 times is going to give you negative 32. So that gives you 1 over negative 32. Well, when you have a negative on the bottom, then the whole thing's just negative, so you plug it out here on the outside. But you have to solve it in here first. If it was negative 2 to the power of 4, then your answer actually would end up being positive. Okay? So make sure you have that correct. All right, let's do this next one. We have 6 to the negative 8 times 6 to the 8. Well, when you're multiplying bases that are the same, remember you're just adding the exponents. So negative 8 plus 8, which gives you 6 to the power of 0. Well, anything to the power of 0 is just 1. Yay. All right, number 4. So we have the same base, negative 3, and then we're doing division. Well, remember division is just, you take the base and you do the top number minus the bottom number. Okay, so then I get negative 3 to the power of, what's 5 minus 6? Negative 1. Okay, so this is a negative exponent, so I'm going to say 1 over, sorry, this should have been in parentheses, negative 3. Well, if the bottom number is negative, then the whole thing's negative, so you just say negative 1/3. You can write it like this. It's not, I won't count it wrong. This is just a more proper answer. All right, let's do the next one. Now you see they've already given it to you as a fraction. Okay, so you're going to still treat this. Let me get another color here. Let's do green. We have 1 times 1 on top here, and then we're going to do the bottom part here. So 1 over 5 to the power, this is multiplying base numbers, so 7 plus a negative 4, which ends up being 7 minus 4. 7 plus a negative 4, 7 minus 4. So then you simplify that, and you get 1 over 5 to the power of 3. Okay, well then I just simplify. The 5 to the power of 3 gives me 1 over 125. Because 5 times 5 times 5 should give you 125. Good. All right. Last one. Now this one could be a little confusing because you can actually do it 2 different ways. You can either do the multiplication part first or the division first. Either way is going to give you the same answer. So maybe I have room. I'll try and squeeze both ways on here. If I do the multiplication first, I get 4 to the power of, remember you add these, 5 plus a negative 3 over 4 to the power of 2. Well, 5 minus 3, or 5 plus a negative 3, is just 4 to the power of 2, which gives you 4 to the power of 2. If I simplify that, I get 4 to the power of 0, which is just 1. Let me show you if I did the division first, because it really doesn't matter. Where's my eraser tool? Yeah, that's it. Okay, so if I do this part first and do the division, I get 4 to the power of 5 minus 2, and then that times 4 to the power of negative 3, right? Well, what's 5 minus 2? 3. Which gives you 4 to the power of positive 3. So then when you're multiplying, you just have 4 to the power of 3 plus a negative 3, which is 3 minus 3, still gives you 4 to the 0, which still gives you 1. So either way, you get the right answer. So whichever way your brain naturally sees this, go with that way, because that's how you'll remember it the best. You're still simplifying the bases and the exponents, so it all works out. All right, let's look at the next example. All right, for this example, it's going to show you how we simplify where we're starting to get slightly more complicated equations, but as long as you follow the rules, guys, it works out just fine. So you can see here we have negative 5 x to the power of 0. Well, we know that anything we plug in for x is going to come out to be 1 because it's put to the power of 0. So you see here they've replaced -5 to the times 1 because there's no reason to put an x there. Well, -5 times 1 is just -5. Okay, so that's a quick, simple one. Let's look at a slightly more complicated one. So for B, make sure you're writing this in your journals. Pause me if you need to. You have 9y to the -3 divided by y to the 5th. Well, you don't have any number to deal with the 9. You see how there's no number in front of the y? There's no coefficient. So the 9 you just rewrite. You see they did that over there. So what we're simplifying here is the base y and its exponents by doing division. Well, when you divide exponents, you actually subtract. So -3 minus 5. So 9y, whoops, I skipped ahead on accident. Oh, well, I'll leave it there. 9y to the -8 because -3 minus 5 goes further, -8. Well, you can't leave a negative exponent, so this is where you simplify. And you would technically put, let me see if I can write it on here. You have 9, and then it's kind of like saying times 1 over y to the 8th, because remember you're supposed to put 1 over y to the 8th, but you see here 9 times 1 is a waste of time. You can just write it as a 9. So think when I have a base to a negative exponent, I just need to put it below into the denominator. You don't necessarily have to have that 1. The 1 is a placeholder if you don't have another number up there, but in this case we have the 9. So your final answer is 9 over y to the 8th. That's the final answer to this one. So let's do some on your owns. Grab your paper. Okay, I'm such a nerd. I love this kind of stuff. This is the stuff you will see a lot more when you get to algebra. I think you see it in algebra 2 even more than that, but that's fine. Let's see. Let me open. Okay. So, let's look at the first one. We have 8x to the -2. Well, the 8 doesn't really have to deal with the exponent, so I'm just going to rewrite the 8. And then I have x to the -2. Well, x to a negative power, I need to put it underneath the divide. You would put a 1 up there if you didn't already have an 8, but I already have an 8, so I just need to write x to the 2. Now, since this is a variable, x, I can't solve it any further than that. So there's your answer, 8 over x to the 2, or x squared. All right, now let's look at this one. We have two parts here, b to the 0 and then b to the -10. Again, I would solve this first. B to the 0 is what? Any number to the power of 0 is 1. 1 times b to the -10 is just going to be b to the -10, right? So this whole thing becomes irrelevant. So I'm just solving b to the -10. Okay? Well, I can't leave it as a negative, so I have 1 over b to the 10th. Ta-da! All right, last one. All right, so I have z to the 6th over 15z to the 9th. You can think there's an imaginary 1 right there if that helps you. The 15 stays on the bottom because we're not simplifying the numbers, the coefficients. We're just simplifying the exponents here. So when you're doing division, what do? We do subtraction of the exponents. So I actually have z to the power of 6 minus 9 over, and I leave that 15 there. Okay, well, what's 6 minus 9? 6 minus 9 would be -3, right? Leave the 15. I can't have a negative up here, so I'm going to bring this back down to the bottom to make it positive. So then I have 1 over 15, because it never left there, z to the power of 3. And there's nothing else I can do to simplify, so that's my final answer. All right. I think we have one more example. All right, so we're doing I knew I accidentally opened 2 of these. Delete this one. All right, so we're doing a word problem here, and it talks about a faucet. And a drop of water leaks from this faucet every second. How many liters of water leak from the faucet in 1 hour? So there's two parts to this. First, we need to take our how much water drops per hour, because it asks us how much in an hour. So it told you that it leaks a drop every second. So we need to find out how many seconds are in an hour. Well, remember how we converted hours to seconds a few lessons ago. So 1 hour, you convert it and you get 3,600 seconds. Okay, so we know there's 3,600 seconds in 1 hour. So now we can use the information they told us, which tells you that 50 to the power negative 2 is how much of water drops per second. Okay, so now we're going to multiply it by the number of seconds. So you have 3,600 times 50 to the power of negative 2. Well, first you need to simplify that. 50 to the negative 2 has to be 1 over 50 to the 2. Then you can simplify that. 50 times 50 gives you 2,500. Then you multiply straight across. So you get 3,600 times 1 over 1 times 2,500, which gives you 3,600 over 2,500. Lop off those zeros, you get 36 over 25, which gives you the fraction 1 and 11/25, or 1.44. You can leave it as a fraction or put it as a decimal. I don't care which one you want to do. And your final answer is to know that 1.44 liters of water leak from the faucet every hour. All right, grab your paper for the last on your own. I'd keep your journal over because it's dealing with, of course, the last example. So they said, what if in example 4, the faucet leaks at a water rate of 5 to the negative 5th liter per second? How many liters of water leak from the faucet in 1 hour? Well, remember, we already figured out that there's 3,600 seconds in an hour. So we're going to use that as our multiplication. So we're going to say 3,600 times 5 to the negative 5. Okay, well, you got to simplify that, 5 to the negative 5, so I'm going to rewrite 3,600 times, the negative makes me put it on the bottom, so 1 over 5 to the 5. Then I get 3,600 times 1 over, well, 5 to the power of 5 is 31/25. So then I simplify this. Remember, this becomes over an imaginary 1, and you multiply straight across. You get 3,600 over 3125. So then you do 3,600 divided by 3125. And you can either put it as a fraction or a decimal. In this case, I'm putting a decimal. 1.152 is a word problem, so make sure you label it liters. So this faucet's leaking more at 1.152 liters per hour. Actually, this is less. The other one was 1.44, huh? Sure enough. It is less. Oh, it's a negative exponent. Silly me. So, smaller. All right, so there is your final answer. Okay. If you have any questions, please don't hesitate to ask. Make sure you're using your journals with these rules on there so you don't forget what rules for negative exponents. Remember that anything to the power of 0 is just 1. And then if you have a negative exponent, put it under 1. So you've already done on your own numbers 1 through 7. 1 through 7. They're supposed to be 1 through 10. Let me check. We did 10. I was looking at the wrong thing. So we've already done 1 through 10 on your paper. So there's a bunch of free points for you. You need to do, lost my place again, numbers 9 through 16, and then also 20 through 27. All right, good luck.